In this lesson, I'll show you how to solve related rates problems with derivatives. This is question 3. The question reads, Ship A leaves a port P and travels west at a speed of 11.5 kilometers per hour. After 2¼ hours, Ship B leaves port P and travels north at a rate of 19.4 kilometers per hour. How fast are the ships separating 5 hours after the departure of A? Let's start with a quick illustration. We have a port P, and we have one ship that is moving west, that's ship A, at a rate of 11.5 kilometers per hour. So we'll represent this dot as ship A. And we have another ship that is traveling at a rate of 19.4 kilometers per hour, and we'll call this point B. What we have to find out is how fast the two ships are separating at exactly the 5-hour mark. To do this, we need a formula that will relate both A and B together. The formula that I have in mind is the Pythagorean theorem, because this is a right triangle, and the Pythagorean theorem will relate this side and this side. If you recall, the Pythagorean theorem is a squared plus b squared is equal to c squared, where this over here, this line, represents your hypotenuse c. Now to find the distance from A to P, we need to take the speed of 11.5 and multiply it by the time. So the distance from A to P is 11.5 times the time. And similarly, the distance from B to P is 19.4, and unlike in the distance between A and P, it'll be time minus 2.25. Remember, ship A had a head start of 2.25 hours. So to factor that in for the distance between B and P, we have to subtract whatever the final time is from 2.25. And that's shown right here. Next, what we have to do is substitute these expressions into the Pythagorean theorem equation and take the derivative with respect to time. A will be denoted as 11.5t plus this expression to the power of 2, and I can start to simplify this expression by expanding, so I'll do that as well at the same time, where I have 19.4 times negative 2.25. That gives me roughly negative 43.65. So plus 19.4 t minus 43.65 to the power of 2 is equal to c squared. I'll take the derivative of each of these terms individually, and to find the derivative, I will use the chain rule for this expression by bringing this 2 down, taking the derivative of this, subtracting this by 1, and multiplying the expression by the derivative of 11.5t. 2 times 11.5t, 2 minus 1 is 1, and the derivative of 11.5t is simply 11.5. Similarly, I'll do the same thing here, plus 2 times this expression, 2 minus 1 is 1, and the derivative of this is simply 19.4, is equal to dc over dt, and the derivative of c to the power of 2 is simply 2c. This is what we're looking for. This is our end goal. So we have to now isolate for dc over dt. And I can do that by dividing both sides by 2 times c. Dividing both sides by 2 times c gives me dc over dt is equal to, and I'll simplify as much as I can the expression that was on the left side, 11.5 times 11.5 times 2, 11.5 times 11.5 times 2 gives us 264.5t, and I'm going to simplify this as well. 2 times 19.4 first, that gives me 38.8. This part's next. Now I need to expand 38.8 with these two terms. If I do that successfully, I should end up with these two terms are like terms and they can be combined. I'll do that right now. 752.72 plus 264.5. That gives us 1017.22. Now that I have the equation simplified, I can substitute my given values. They told us after 5 hours, so t is equal to 5 hours. And we don't know what c is, but we can easily find out what c is by substituting 5 into this t, and isolating for c. Let's go ahead and do that. So use your calculator. Bracket 11.5 times 5 to the power of 2, that covers this term, plus 19.4 times 5 minus 43.65 to the power of 2 is equal to c to the power of 2. Now we square root both sides, and this gives us 78.5. Let's write that down. C is equal to 78.5 kilometers. Let's substitute these values and finally get our rate. 1017.22 times 5 minus 1693.62 divided by 2 times 78.5. Once again, our final calculation will be 1017.22 times 5 minus 1693.62 divided by this expression, 2 times 78.5, giving us a rate of 21.6 kilometers per hour. 21.6 kilometers per hour. This tells us that after 5 hours, at the 5-hour mark, the boats are separating at a rate of 21.6 kilometers per hour. And there you have it. That is how to solve related rates problems with derivatives.